Our next speaker is ready to go. Please welcome Mr. Liran Tal from Snyk Node.js Foundation. And the topic would be about malicious modules on NPM, a series on unfortunate events. Hi, Liran, how are you? How's it going? You're muted now.
Oh, yeah. There we go. Yeah.
Cool. How are you? Are you excited?
Very excited, thank you. Setting up everything here so we can go live when we're ready.
We are ready. I can see your screen. We can hear you, so everything's fine. You're ready to go.
Sounds good. Can we get started, or are we waiting to catch up a bit on the time?
No, we are on time already, so you can start.
All right, awesome. Well, hi everyone, and thank you for joining. And it's my pleasure being here and chatting with you about security matters on the NPM ecosystem. Today, I want to talk to you about malicious modules on NPM, a series of unfortunate events. So as you know, I've probably heard about some incidents that have been happening on the NPM ecosystem on JavaScript, and not just on that. And today I want to actually walk a little bit into it in terms of examples and code and what can actually go wrong and what can we do together as all of us as citizens of open source and this ecosystem. So I'll start with introducing myself. My name is Liran Tal. I'm a developer advocate at Snyk, where we build developer-first security tools for open source. I'm also involved with several security activities, such as the Open Web Application Security Project, which is also known as OWASP for short. I'm an active member of the Node Foundation Security Working Group, so I'm helping triage vulnerabilities from time to time. If you want to join that, we could always use a bit of help, and this is like an open source and open community kind of project. So if you want to join, if you want to help in, just find me on Twitter at Liran_Tal, or ping me in whatever medium is most easier for you to access. So with that, I do want to kind of talk to you on what we'll be doing today in terms of this session. So I want to talk to you about black clouds and silver linings in terms of everything that could go wrong in our ecosystem and some things that have gone wrong. And this kind of having this notion that with the growth of this open source software, that we all are using, we can't forgo the importance of security aspects that are affecting both developers and maintainers alike. So in this talk, we'll talk about discuss specifically some software supply chain security. So things like getting better insights into dependency management that we all are dependent on. Learn more about popular vulnerabilities and how to fix them. And last but not least, I want to talk about some security controls that you can have in the NPM, the Node ecosystem. So everything around JavaScript and everything that we have to protect you. This is, of course, by all means, not a very comprehensive best practices, but at least a very good starting point for you. And I have a lot of resources afterwards, so you're always welcome to just ping and reach out. So let's talk about NPM, right? The largest open source repository of application dependencies, spanning over 1 million packages. I think 1.2 million last time I checked. So it's pretty big, right? And I do want to get this statement, kind of set the stage for this talk. I want to open this with this quote from a research paper from Zimmerman et al. That dived into a lot of the aspects that open source security has in it, and just let it resonate for a bit. That installing an average NPM package introduces an implicit trust on 79 third-party packages and 39 maintainers, creating a surprisingly large attack surface if you compare that to other ecosystems, for example. So NPM is kind of heavy on reuse, right? We write a lot of node modules. We also use a lot of node modules. There are some node modules that are built of under 10 lines of code, some under 40 lines of code. Maybe that is not necessarily bad, but it should indicate to you that, I think as JavaScript engineers and NPM as a repository has a unique culture of small purpose built modules and kind of a tendency towards reuse. So let's take a practical example. If we, for example, try to compare Java to NPM, if we take Spring as a web framework, it has 10 transitive dependencies. And if you compare that with Express, it has 47 transitive dependencies. Express is probably a good case in terms of most of those modules are probably built by the maintainers of Express. but not all the time this is the case. So you should actually know about that and understand that this is an actual concern that we have. So yes, a testament of JavaScript's incredible growth is probably NPM becoming the largest open source repository with more than 1 million packages, as we said, more than 70 billion downloads a month. So it's a really, really big repository. And what I'm getting at is the biggest repository also kind of invites some big risks that we need to understand and be aware of. So first of all, it's I'll start with, it's a very lucrative attack playground in the sense of compromising one popular package impact tens or hundreds of thousands of other packages that are transitively probably dependent on it. And that translates at the end of the day to like millions of downloads, by consumers, by you, me, and all of us together in this game. The other thing is it is a very open ecosystem, very much unlike other ecosystems as well, in terms of anyone can submit any module that they want, without being required to like specifically validate their identity through something, very identifiable, like a mobile device or something like that. So just, signing up with an email, create a package, publish it, and that's it. Even if that's a malicious package, out of 1 billion packages, that's probably it will take time until someone catches up with it. So it's very lucrative. It's very open. It's also very difficult to detect as kind of like maybe a last item. But before we even get to that, let's think about this thing where we're talking about an open ecosystem. So we have a very big disconnect at the moment between NPM from what you publish to the source code that actually used to create this package. So there's nothing that says, when the package has been published to NPM, it actually relates directly to this and that tag or branch on, GitHub or Bitbucket or something like that. So there's total disconnect, and you could have one thing on SEM and the other thing on NPM as like a tarball. And then the other issue is the bunch of people that are maintaining the software on something like GitHub, like an open repo, is not the same as those publishing it. So there's again a disconnect between committers on like the Git repository and then the publishers for that on NPM itself. And then it goes again back to difficult to countermeasure in terms of NPM is really big. To auto detect a lot of malware in scale, it takes a lot of good technology and resources, people developing all of these things. And I think we're not yet there yet, but there are some indicators that NPM is kind of like growing into that space. Recently, they had shared around this thing called Insights API, which is in kind of like closed beta, so probably worth to sign up and see what they have to like help us all around this context. So moving on, I want to talk to you about, the small world with high risk, this study of security threats in the NPM ecosystem that, we can pull some interesting perspectives on the state of security in our JavaScript ecosystem just from this research paper, which, as you can see, hasn't been published long ago. So one of the highlights from this research paper is just how much we are reliant on transitive dependencies. And in this chart, we see that by linearly adding dependencies to our project, we actually incur a super linear increase in those transitive dependencies that are added as a result. And another 2019 academic research paper that explored the differences between Python's pip, which is Python's repository, and JavaScript's NPM, which is ours, in this ecosystem, found that an average NPM install will yield 4 levels of nested dependencies of packages that you may not understand exactly what is the security testing, the security posture of, etc. So in this research, this one from Zimmerman, they actually found out that when you install an average NPM package, a user implicitly trusts around 80 other packages due to these transitive dependencies. And I can't help but wonder how many of us, are truly aware of all the dependencies that we actually have in our projects. Do we trust these maintainers? Do we know if these maintainers have, ran any sort of security test on their packages? Which it is all in good faith, but we need to understand that, we are bringing in these dependencies and it carries risk. So how about the fact that up to 40% of all packages rely on code known to be vulnerable? Again, also insights from Zimmerman's, research paper. Let's talk a little bit about malicious modules that take different forms at all in how they manifest and how we actually have seen them. So there's typo squatting attacks, there's compromised accounts, social engineering, and we haven't even seen yet a case, where the NPM was actually breached or something like that. We probably will not see that. Hopefully, we'll not see that. But all of these three cases, at the very least, have been happening, and we've seen incidents around it. So malicious modules. I'll start with the first one called crossenv. It happened a bit while ago, but we can learn some things from it. So when you wanted to install crossenv, which generally speaking, crossenv is a good module to manage your environment variables. But if you wanted to install it and you installed maybe the wrong thing, like if you typed that one in, it would actually install a malicious package, because it actually needs to have a dash and not without a dash. But if you installed it, and we take a look at how the package JSON, for example, looks like from this malicious module, you can see it's called crossenv, like that. It's been defined in it, but it actually bundles the real crossenv to give you a sense of an actual functionality, even though this is not the same, it's not the same module. But more than that, it has this post-install script that when you install packages, npm as a command line package manager, client-side package manager allows packages to run arbitrary code in the same, in the same user that actually runs npm itself as well. So generally speaking, those packages can define some hooks, like when you finished installing the package, I also want you, which is basically downloading a tarball and extracting it. I also want you to execute this package setup script, which if you did, it would go ahead and run all of your environment variables and send them off to an attacker, to the malicious user here. Let's see if you can spot the malicious package out of these options. If you were to install CoffeeScript in 2020, would you install the first or the second? But the thing is, CoffeeScript, the one that you actually install is not the left and not the right. It's actually CoffeeScript without just spelled correctly. And we're seeing these packages, malicious packages, happening a lot. This is like a snapshot from the Snyk vulnerability database. It's just open, so you can go and browse through different ecosystems and just see all the CVs and vulnerabilities that are out there, including malicious packages. You can see that we're seeing them quite a lot. And this is an example for their request package, which, as you can see, there's different ways of typo squatting it in the npm ecosystem. So what we learned so far, at least, is there's post-install script that we are aware of, and they can do something like call home with the base64 payload. So maybe they get passed through firewalls and things like that. How did we find out about this malicious package? So actually, it was something that the community found out about it. And we actually, when we did find out about it as a community, we also realized that this is not the only malicious package that the user had actually created. They actually typo squatted 40 other packages as well, trying to kind of like trick users into installing the wrong package. Let's talk about something else, about get cookies, which you could figure out that this maybe is something to allow you to parse and manipulate HTTP headers for cookie data, or does it, right? So what get cookies actually is about is, in fact, it's nothing less than a command and control backdoor that allows anyone who knows that this is running on a remote server, and any victim who had installed it, it allows a remote user to actually execute remote commands JavaScript on a running web server when they bundle this dependency. How does it work? These are all real stories, right? So this is a real dependency. How does it work? The attacker actually built a pyramid of all of these meta packages that actually just wrap get cookies, because no one looks behind a node module of a node module of a node module, but still it's just 3 of them out of like a million packages. So to get it to actually kind of like circulate around the ecosystem and gain some downloads, they were able to actually in reality compromise and hack the account of the maintainer of mail parser, which may have probably used did not use two-factor authentication, or may have used weak passwords, and so they were gaining a lot of they added get cookies as a dependency to mail parser, and basically gaining a lot of monthly downloads out of that. Now we said command and control. So how does this backdoor work? This is like a real backdoor. I've kind of like we'll go through the process. It's 40 lines of code payload, but it's not a lot. But we'll need to run through it through some of the slides. So as you can see here, I bet this looks a bit familiar. This harness function is like a function signature of an Express web application server, which that's what it is. And the heart of like the whole thing, the whole payload is actually this kind of piece of code where you see that at first it tries to allocate 64 bytes of data onto something where it can actually like inject some data into. Then it looks for like a specific string in the headers. So maybe like something that it can actually send over the HTTP to control and like send data or send commands. It will go and parse it in little endian form. And then we can distinguish from these three different commands being handled. So one of them allows you to go ahead, one of them allows you to go ahead and reset the buffers. So like the buffer is empty. The other one is actually going to push data onto the buffer so we can push our JavaScript code onto the buffer. And the last one is all about executing it. So when they have finished the attacker sending their code, they will send it off and execute it. So you can see all of this payload here, and you can go through it. And the way that something like that works is, imagine someone is just if they are able to interact with a web server that has this malicious package being bundled in. Just imagine that they are just sending an HTTP request. You do not need specifically to be authenticated if that is not required, but they add their data in this X secret kind of like HTTP header. And then you see these commands and these strings afterwards are basically used to reset the buffer, load some JavaScript code, and at the end execute it. So all of these real stories from of course that has been happening on the ecosystem with mail parser and get cookies. Mail parser got published with 3 versions, all of which were vulnerable. We're basically carrying off this malicious package as well. So one observation we can take here at this point is, security by code review is really hard because we have to get it right all the time when we do code reviews of packages by packages. But that's not the same for attackers where they have to be, lucky just once to get in. Let's talk about eslint-scope 372. It's basically a malicious package that was published to the ecosystem as part of the whole ESLint project, or the whole eslint-scope specific package, which is okay, just not this specific version. And what happened there is, when eslint-scope was actually compromised, what it did is something very similar to what Croissant did, a year before that. Instead of eslint-scope, instead of getting and gaining environment variables and sending them off, because you usually have maybe sensitive data draw like API keys and passwords, what eslint-scope did as a malicious package, it sent your .npmrc file, which is where as a user and as a maintainer, you have your tokens. And so if you have your npm tokens, then this is something that we can use now to maybe access your account if you maintain some of this. So this happened, as you can imagine, millions of downloads for eslint-scope, since this is a very very prominent project in the ecosystem. Not millions of downloads though for the malicious package. So we actually caught that in time, and what was going on there is like the same thing that we've seen before, right? How do you do that? Basically, there's a post install script that you execute, and here is the payload for it. That's a pretty interesting thing. So if you think about static code analyzing and like what can you do to figure out all of these malicious kind of like code and payload that is happening. So if you think about it, if the code is not existing there, then it's really hard to find it. So what they have done here when they compromise this package is they're actually doing a GET request outside to something public like Pastebin, where they have maybe like an encrypted source of, or just not like an unencrypted one, of what they actually want to evaluate on runtime when this script gets executed. And that's what they actually did, right? Those of you who might be looking very closely here can see that there's actually a JavaScript mistake in a sense here. So there's a stream being opened to this HTTPS host, except when the data payload just gets back, it's going to go and try to evaluate it. But the fact is, it could be a very big data, so it will not actually fit into that chunk of the data that is being handled for us in the stream traffic that we get in this function. So when that happens, there's going to be probably like an error being thrown, and this is how we found out about it when someone was actually being attacked and kind of like infected by this malicious package. they had this error, and they opened an issue on GitHub and say, no, maybe this is a virus because it looks very weird and it likes doing something that I would not expect it to do. So this is how we actually found out about these kind of things. Who depends on the eslint-scope. So if you're not aware of this project, things like Babel, like Webpack, all of these are dependent in one way or another, at least at that point in time. Now, it wasn't severe in the term of its impact on the amount, like there wasn't millions of downloads as far as we know to this package, but it was severe enough for the NPM team to just basically invalidate all those tokens that they issue through NPM-RC and stuff like that. Invalidate all of them prior to this, after this has been discovered, and at least from their estimation on the blog announcement back there is about 4.5K accounts that were compromised through this. So maybe a second observation here. So eslint-scope published a package on NPM, but these malicious actors did not have any access to the GitHub repository, which would have been maybe easier to spot. And this is when we said, big ecosystem, big risk, etc. This is like there is no connection between the source code and what you get on NPM, the actual tarball that is being published. So something we should think about. But again, like how does something like this happen, right? Like how does someone compromise however they build their malicious package? How do they compromise something as significant as the eslint-scope or mail parser, which have hundreds of thousands of downloads or millions of downloads? So a security researcher actually evaluated the possible case of basically people using weak NPM credentials, weak passwords to a sense, and managed to gain access to what accounts to be around 14% of all modules on NPM. So he was basically testing to see if they are able to gain publish access to modules on NPM, right? And they had actually managed to get that to about 14% of all NPM modules. There's a link here below. I'll share my slides afterwards. This is the person, and these are the notes. All of these are real cases from the ecosystem. And maybe you are familiar with at least some of these. Just a sec. Slides. There we go. Maybe if you are familiar with some of these modules that they were able to gain access to, because if we convert these 14% modules of all NPM, they actually account for 20% of the total monthly traffic on NPM. And gaining access to things like React and Moment and Express and all of these modules that they actually were able to gain publish access to. So it is shocking, and let's figure out how does this happen, and so that we can learn from it and not do the same mistakes. So for example, Koa maintainers had their password set to password, which is probably a bad idea. So please do not underestimate your credentials to NPM, GitHub, or anywhere else. About more than 1,000 users, just had their username, their password set to their username to publish a package for their NPM user. So again, telling you do not use bad passwords. Even if you used really, if you think you are using a very good password in terms of, maybe it's very long, etc. The thing is, you have to take into account that a lot of time passwords due to data breaches get leaked. And they were able to actually compromise those accounts and gain access by basically consulting these leaked databases. And basically, for example, one of the users that was directly controlling about 20 million downloads a month for a package simply used their last known password, which was leaked, by just adding one character to it. So it was very easy, even if it was not exactly the same one, to just realize what it is. So again, good security hygiene starts with your developer practices, things as really as easy and simple as working with passwords. And to Efrain, we'll talk about it to the last part of the slides. So how about the fact that one of those security research papers mentioned earlier that it found 61% of all packages on NPM that could be considered abandoned. And they defined an abandoned package as one that did not receive any new version published in the previous 12 months. Now, this may be something that you would, counter argument with things like, maybe it's a package that is very mature, there's no many updates necessary, except we've been aware that, event stream happened. So, November 2018, the event stream, to my opinion, one of the most sophisticated and biggest issues that we've seen around like open source malicious modules in terms of people being able to take over event stream. And I do not want to go into the details because it's generally like a long story of how this whole thing folded out. So there's this postmortem here. There's a whole there's a bunch of blogs around it. This is one from the Snyk blog on like a postmortem of what happened here. But to make a long story short, what happened is basically social engineering attack that get attackers to actually gain access and control over a popular package because they had social engineering the way in saying that they want to help, they want to contribute packages. One of those were then found to be malicious after several versions, and it actually got them to target specifically developers of Copay Bitcoin wallet application and injecting malware there to steal Bitcoin money. So they specifically targeted developers in the way that the build flow actually works. And most of us would not even be familiar with event stream because it's not really used as like a direct package, but it is used a lot as an indirect package. And the thing with event stream is that it shows us just how easily attackers can infiltrate open source software supply chain by just adding a malicious dependency to a trusted component. It is actually about maybe 1,000 packages behind from being the top package, event stream itself. And still this has been one of the most dangerous things that and the scariest thing in my opinion that we've seen happening on the NPM ecosystem. So that's not even close to the top package, and it has made significant waves. Maybe the last observation for us in this module basically is due to the increased use of transpilers, reviewing actually and comparing source code, even if you could do that between actual source and what is actually distributed on NPM is very hard because a lot of time, especially around front end, you will go ahead and have like a distributed like a dist folder that gets transpiled. So not like reviewing that doesn't make a whole lot of sense. And so this brings us to talk a lot. All of these stories we talked about, things that could go wrong, and I'm not here to preach that we have a bad ecosystem. Far from it. I think this is an amazing ecosystem to be part of. But this is all to educate us on things that can go wrong, and then be a little bit more vigilant on on the action that we do, on the packages that we install, and just being a little bit more responsible than just going into the terminal doing npx something without understanding what you're installing. So just having this mindset. So dependency management, as all of this brings us to, is it's very hard to imagine, I think, anyone building anything today without using open source, whether it's backend, front end, web, or anything else. So dependency management is hard. These are libraries that we use across projects spanning beyond not just Node.js and into other JavaScript platforms as well. And this ecosystem is very convoluted. There are many libraries, and other nested libraries, and future libraries coming out. So how do we make sense of it? What can developers, when we're talking here about security, what can they do to secure their application a bit better? To have it is also a hard time to actually keep up with all of these nested dependencies and understand all of those security implications. And so let's do a mental exercise, right? Imagine you're building a Node.js app. Imagine you're building a JavaScript app. Most of the time, your mental image of the application that you're building is this blob, except it shows you, it provides you this wholesome, end-to-end functioning application, except in reality, what you actually write in terms of your own code is probably a lot smaller. And you don't have to just trust me on this. There's many research data from Gartner and those kind of firms that are actually mining these data, understanding what's going on. They're saying most of the code that getting shipped, getting deployed, getting built is made out of 80 or 90% of open source code, not like proprietary code that developers write in organizations. So this is what we have to handle as developers and understand this kind of security risk. And it also brings me to the notion of what is the maintainer kind of point of view here. How do we roll out security fixes? So for example, dependency management is hard. So it's not just for us developer, maintainers also have to kind of like keep up with those security fixes and also release them. So the screenshot shows you like a GitHub issue where developers actually surface a problem in which the maintainers have released a version to fix it, but they released the version, the new one that fixes it, as a major version, as 3.x versus 2.x. And that makes automatic upgrades a little bit slower and more complicated, because then it's not a minor or it's not a minor semver kind of upgrade or a patch. So if it's a major one, maybe we need to like take into account maybe there's like breaking changes and API changes and stuff like that. So we need to understand also how to roll these out in a better way as maintainers. And so this brings me to like another interesting insights, and that is how often we, as both I think maintainers and developers are on like this autopilot mode where we don't even consider security risk and attack vectors that are, in the most basic things, things like a log file. So why would that even be a risk if you're using a log file? So let's imagine this case, which is a real example that I've reproduced. And imagine someone contributing something to you and your to like an open source project. So you see there's like a couple of packages there, and like basically I didn't even change them. I really just upgraded your versions. And if you were really, really cautious and you did not know them, of course, you should have gone and checked that what is types node and what is octokit rest, and just realize these are like actual okay packages. But if you take really good notice here, you'll see that the log file itself, in this case, yarn.log and package log behaves the same. Because it is actually very big in terms of changes, GitHub will actually go and make it show it like that in terms of it will be collapsed, and so you will not see all of the changes there, because who can review 500 lines of code changes. But if you were to go in and see what was actually going on there, then you would see that I would actually, in my pull request, I actually went in and changed this like HTTPS registry npm.js to get the MS package into github.com in a repository that I control. So if you did not review this, what would happen for you next if you were working on this project and doing like an npm install or yarn install after keeping up with the project development as a developer? It would actually be pulling in my version of the MS package and basically be able to compromise you in that sense. So now we actually need to understand that people can hide backdoors here and some other malicious data that they want. So we actually need to go ahead and this is another security concern when you use log files. And so luckily there's a tool for this. I built this thing called logfile-int, which helps us go ahead and have like security policies and say make sure that everything is coming only from npm and yarn, do not allow GitHub, or validate that everything is under HTTPS and nothing is not HTTPS, etc. So all of this is good tooling that helps us out. Let's see an example of code injection. Let's talk about actual vulnerabilities that that appear in the ecosystem. And so I wanna go out of like of the presentation mode, and I want to show you an actual vulnerability. So let's say this is our app. Let's hope that it will. There we go. And we have it. This is a very simple to-do application. As you can see, I can add some stuff here. Doesn't really matter, but it has this, this about page, and I think it even has this about new kind of route that will give us about data. And the way that we built it is using something that's called a templating engine, like Pug, like EJS. In this case, we used something that's called .js, and it takes all of this device variables like desktop or mobile, and so it can give you kind of like the dynamic sense of building the page. And so the way that this works is, if you look at the actual code, you'll see that it has this condition where device equals device, and then it will do something here. And if I take a look at what happens in terms of, well, is Dust, which I'm using here, is actually secure or not? So my version obviously is not, since I'm using actually the vulnerable version to show you the example here. You could, but see, like, what is code injection and how does that look like, which is what I'm trying to like make the point here. So just to educate you on how this actually manifests. So if you think about it in terms of Dust itself, this is a very, actually it's intended to be a very secure library, and you can see like the dependency in a way that it manages data. And so it has this escape HTML, so it allows us to actually escape data, and it checks if something is a string, and if it is, it will go ahead and encode it, and so on. And so for me, if I wanted to go ahead and see what I can do is maybe I can go, since I know there's an evil going under, I could go and add some escaping characters to escape it, which doesn't really work. But the thing is, to exploit this, you have to understand a little bit more. So what is going on here is basically a thing that's called HTTP parameter pollution, which means I will be able to impact the way that the device character works. So it's not longer a string now, it's an array. And so it kind of behaves the same. As you can see, nothing was broken. But as soon as I add something like an escape character, this messes things around. And what happens behind the scene is that evil gets broken. So let me show you how this looks like from the command line perspective, that you can see how I am able to actually inject something into this website. So basically, this is a website. This is like the same query that we did before. If I launch it, I'll see some input. And on the left, you'll see there's a console log I'm doing in my request. So this is OK. But as soon as I know that there's like a code injection there, and I can know how to exploit it, I can send something like, I will terminate this whole eval statement here. And I will go and fire off a function. And then I will continue the rest of the statement so that my code won't get broken like it did when the evil like misses this single quote. So when I do that, you see that it kind of like looks like nothing. We did nothing. But if you look again on the left side, you'll see that now this console log shows you what I sent, and also actually executed console log 1. So at this point, I actually executed data on the server, actual JavaScript on the server that was evaluated in runtime. And I could have just as well done things like here, like send the payload with required process, like require a child process, execute some commands, or get me some sensitive files that you have, or whatever I wanted to do basically on this server. I could just execute it with the permissions and privileges allowed to this web server. But there's more on this vulnerability if you want to see like the actual details and go into it. I'll be happy to review more of that afterwards as well. So let's go back to like the silver linings in the ecosystem, all the control and what we have so far, around all of this, around all these security stories that we talked about. So first of all, how many of you have 2FA enabled to this date? Because it has been there since the end of 2017, so for a long time. And by now, you probably should have 2FA enabled in your account. The stats that I collected, at least from like somewhere around like last August or so, so it is a bit outdated in a sense. But I really doubt it goes much higher than a 10 or 15%. So this is the data that we had public since then. And this is what we have to work with, right? Only about 10% or maybe 15% if we want to do a visual thinking here of people having leveraging 2FA. So please, if you haven't understood that message from me so far, please go ahead and enable 2FA accounts, 2FA in all of your accounts on NPM on GitHub, so that we are all a little bit more secure. You can do it from the CLI as well as from the UI. So whatever works. Other thing is 2FA, it has some caveats in terms of, well, if you want to do automatic releases with things like semantic release, then you need to be able to provide the tokens, but that doesn't really work if you have 2FA enabled. So if you really care a lot about this issue, you can go to the package maintenance working group. There's an issue about it, and like participate. And if you want to offer some ideas, hopefully you are using something like npm audit or Snyk, whatever works for you again. In your workspaces. So this is like one good example to go ahead and stay up to date with vulnerabilities. What Snyk makes it a little bit easier is just in terms of if you do integrate with that, then it will actually create a CI integration, like a pull request into your like a CI into your pull request. So basically, anything that gets opened as a pull request will get validated in terms of like maybe there's like a vulnerability being sent, and so it will break the build and so on and so on. You might be wondering, are we seeing more or less security vulnerability issues for Node.js? So for the last couple of years, there's definitely a lot of tremendous growth that, as you can see here, in terms of the vulnerabilities being reported for the NPM ecosystem. But this actually isn't specifically a bad thing. Actually, it's been cited by Zimmerman's security research that this is a sign of a very healthy security ecosystem, that actually, people care to report and, process vulnerabilities, as, when they get discovered as well. So, this is a sign of a healthy ecosystem. This is great that we are having all of these conversations, all of these talks around security ecosystem around NPM and JavaScript. If you do want to join us, this is kind of like doing a full circle and a closure here. Is there's the Node Security Working Group. It's been established, since the late 2016. It is comprised of people, just are, very passionate about security and open source. So we meet regularly. It's all being broadcasted, very open. If you want to take part, go ahead and check the Node project. So Node.js/security-wg, or just ping me or find us. It's not going to be hard. So we're all part of this like developer awareness. So I wanna thank you all for being for joining this session. And if you have any questions, I think we'll go into this now. So that's all for me.
Yeah, exactly. Thank you for this amazing speech. I'm pretty sure that people liked it. And yeah, I've already sent a link to the Q&A room. It's going to be